Welcome to this video. Today we will demonstrate the online monitoring of the three-phase transformer to detect and discriminate the interturn short circuit fault and coil displacement by using the search coil for the three-phase transformer. This method uses the concept of mutual inductance as the voltage induced in the search coil is depend on the mutual inductance. This online condition monitoring using search coil is performed on the special design 10 kVA transformer. Its HV side voltage rating is 400 volt, LV side voltage rating is 200 or 100 volts, tertiary rating is 30 volt. HV side current is 14.43 amperes, LV side current is 57.73 ampere oblique 28.86 ampere. This transformer can be connected in star star, star delta, delta star, delta delta. Refer to connection types and HV and LV side voltages. This transformer can be used as in a 8 ways. The experiment number 2, we already discussed about the design of the transformer and how tapping of the HV and LV is brought out. Thus we will see the connection of the transformer for this experiment. This is a complete setup of our experiment. Here you can see the input of the auto transformer is connected to the our three-phase supply, and then you can see output of this auto transformer is connected to the considered transformer. This HV side of this transformer is connected in a star manner, that is the end points are shorted at each other and connected to neutral. Similar way we can see the LV side of this connection of the LV side of this transformer. You can see the LV side of this transformer is open and it is star connected. Also the third winding is the tertiary winding. This tertiary winding is opened and it is used as a auxiliary. Now we'll see how to do the interturn short circuit fault. You can see interturn short circuit fault is done by shorting the number of turns. These number of turns are shorted at different percentage. Similarly, the coil displacement fault is done by displacing the coil. These are the search coil. You already aware about the search coil. In the next part we will see the complete setup of the search coil experiment. This is a complete setup of our search coil experiment. This is the transformer on which we perform this interturn and coil displacement fault. This is the voltage probe. It is connected between the W phase and neutral. This is the inner part of the transformer. Now we'll see the search coil. Here you can see the search coil box. Here this voltage probe will measure the search coil voltage, and this search coil voltage and this voltage are measured on this DPO. Here we see the demonstrations of this MDO. You can see here only one probe connected, so we have to select only first probes, and then in the next part we have to measure the RMS value. So you can click on this first probe and set the channel 1 for the RMS value. In this part we see the application of the three-phase voltage to this auto transformer. Before that we have to connect the voltmeter between two phases of this auto transformer, and then we'll check this point should be at 0, and then we'll switch on this MCB and will increase the voltage. We'll check, we'll increase this voltage up to the 400 volts. You can see this is the 400 volt voltage. This is first phase, V phase, then VW phase is also nearly 400, and then U, that is VW phase voltage also 397. Now same way this connected in the star manner, so the voltage should be in the 400 by 200. Now secondary voltage, that is the between the two, that is line voltage, is nearly 200. So we'll check It is 197. Yes, it is 197. Then it is near to 200. Okay. In the search coil experiment, Kf is the ratio of the induced EMF during the fault condition to the induced EMF during the healthy condition. This is for the ideal condition. As in the ideal condition, this primary input is a constant, but in a actual condition, this voltage is varies time to time. Hence, the Kf is nothing but the your induced EMF during the fault condition upon induced EMF at the search coil during the healthy condition into the input V1 by, that is V2, where V1 is the voltage during the healthy condition and V2 is the input voltage during the fault condition. Now we'll see the condition for the different fault condition, that is interturn short circuit fault and the displacement fault for this Kf ratio. So if the Kf ratio is 1, then that is the healthy condition. If Kf is less than 1, that is the interturn fault condition. If the this Kf is greater than 1, it is the that is displacement fault conditions. Now we'll see the normal operation of this transformer. Here the 400 volt is applied on this transformer. So and in this case, what should be the surge coil voltage? You can see here, this yellow color is the surge coil voltage and this blue color is the input voltage. Now we will see the coil displacement fault. In this case, what should be your the coil surge coil voltage and your input voltage. So you can see here the input voltage and the surge coil voltage. You can see here is toward 31.9 is the voltage, your input voltage, and 1.65 your surge coil voltage. In the next part, we will see the interturn short circuit fault. This interturn short circuit fault is done by shorting the number of turns. In this experiment, we will short the 5% of the turns. So see, here we are shorting the 5%. You can see their spark generated during the interturn short circuit fault. Now this position is near to maximum, so we'll increase this current to, first we'll increase current to 10 and then 15 amperes. So we'll see this is nearly okay, near to 15 ampere. Now for this case, I will see the surge coil voltage and the input voltage. You can see here the input voltage and surge coil voltage. Now again we'll vary this current, that is 15 ampere to 10 ampere. In this case, what should be your surge coil voltage and your input voltage. Now we'll see the surge coil voltage and your input voltage. This is a complete experiment. Now we'll see the observations. For the healthy conditions, the surge coil induced EMF and the primary voltage, you can see this. Now in the healthy conditions, the primary voltage is taken as a reference. Here you can see that this observation is done with the same reference. Now you can see for the interturn fault, the value of Kf is less than 1 and for the coil displacement it is greater than 1. Hence in this way we perform this experiment.